everyone. Thank you for being here this morning. So I hope you were here for Charlie's talk because I think he's going to save me a lot of time in terms of talking about some of the history. And he was talking about the killer app. So I'm going to talk about the killer app for virtual reality for social, for space applications. So human space exploration. Anyone know how long we've been in space? We have had continuous human presence on the International Space Station since the year 2000. So it's now almost 17 years. And here's NASA's vision of future Mars exploration. So right now we've got ISS, and our missions are about 6 months each. It's a matter of hours to get there. It's actually very close by. And in the mid-2030s, we're thinking of a Mars mission to there and back for 2.5 to 3 years in duration. It's going to take months to get there instead of hours. So let's see what we can learn from history, because if we don't know our history, we're doomed to repeat it. So let's think about what lessons we can learn about our long history on ISS. What do the astronauts on station do right now? Well, they're taking care of the exterior. They're doing some maintenance work. They're taking care of the interior. We've got Don Pettit right there doing some HVAC, I think, air filter maintenance task. They're taking care of themselves. We've got Karen Nyberg checking her own ocular structure because microgravity can do kind of weird things with your physiology. Science experiments, that's extremely meaningful on station. We've got Nicole Stott installing a mouse house. We've got cosmonaut Korzun looking at the Russian greenhouse. And we've got this big, beautiful cupola. So they can gaze down on Earth. They take pictures for NOAA, for different studies, and also just to enjoy themselves looking at Earth from a distance. And here's a quick shout out to Canadarm. And we do a lot of educational outreach, public outreach as well. So here's Katie Coleman. She's great with kind of bringing awareness and really inspiring the public. And there's a lot of stuff that we don't see. So they're really living, right now the missions are 6 months long, so they're really living among themselves. They're taking care of each other. They have to do a lot of exercise to decrease the effects of muscle atrophy and bone loss. They're cooking for each other. They're giving each other haircuts, things that you would do on Earth. And perhaps most importantly, they're still parents, siblings, spouses, and so they have those social interactions that they have to keep intact. What they don't do is they don't fly the space station. Mission Control down in Houston does that, along with a couple of other space centers that provide the support. So let's take a look at the distance. Right now, Earth is very close. It's actually just 350 kilometers to station. I traveled more than that just to get here. There's virtually no comm delay. They've got the IP phone. They could call down for pizza if they wanted. Delivery is another problem. Going to the moon, it's a little further at 383,000 kilometers. Now we've got 1.2 light second delay, one way. To a near-Earth asteroid, the Provincial Proving Ground, that's almost 2 million kilometers, and we've got 6.5 light seconds one way. You could still do some kind of communication. It's kind of like a really bad, really bad phone call. You could put kind of protocols in place to get better feedback. To Mars, when it is closest, it's three light minutes, so it's 56 million kilometers. Your hopes of getting a real conversation going are pretty dismal. When it's furthest, which is most of the time, we're at 402 million kilometers. You've got 24 minutes one way. So by the time you pick up the phone and completed your answer or a question, even if Earth had an answer ready, you're not going to hear back for another 40-ish minutes. The current design reference mission is that we're going to go take 6 months to get there, 18 months on the planet's surface until Mars rolls back into a low energy window, so that it's another 6 months to get back. So remember that the astronauts right now on station don't fly station. In this case, the astronauts will be. They're going to have a lot of crew autonomy. Let's look at the vehicle. They are going to, for the first 3 weeks, they're going to pack up in a minivan. It's the Orion, and that's going, here's a picture of the interior, the mock-up at Johnson. Now, it looks kind of spacious with all the equipment and only 2 chairs, with all the equipment ripped out. For scale, here's how big that is. And once you pack the 5 or 6, your big close friends in with all the equipment, all the supplies for the 3 weeks, it's going to get a bit crowded. And then they're going to go into the transfer vehicle. The transfer vehicle, for the most part, they are going to stay near the 2 Orions over there and the transfer hab. That's 11.7 meters wide and about 10 meters in diameter. Just by comparison, the station is about the size of a 5-bedroom home. There's a lot of space. For example, it's made up of many modules. For example, one module is 5.5 meters by 4.3 meters, and here's where they enjoy each other's company. They can have dinner. They have a lot of different spaces where they could be together or work separately. Did I mention that the transfer vehicle is kind of small compared to station? Let's look at the duration. The longest in history of human spaceflight, continuous human spaceflight, is in the Skylab days at 437 days. 2 years ago, we finished our first 1-year mission at 340 days. A Mars mission is going to be 900 days. So here's Karen Nyberg again, enjoying the view from outside. So even if the Mars vehicle has this beautiful cupola, most of the time, they're going to be looking at this. There are a tremendous amount of stressors, environmental stressors, confinement, lack of natural lighting. Remember those long Canadian winters where it's dark and it's cloudy and it's wet? Well, they're not going to have any of that. They're not going to have any sense of season or the spring coming, any sense of weather changes, no changes in temperature. And then there's also a lack of privacy. They're in a small environment, and so there's visual and audio privacy concerns. And there are other stressors like high and low workload. You don't want them to be extremely stressed, but there are also times of potentially extreme boredom. Performance demands, they're constantly under pressure to be on their best behavior. There's the idea of no abort and no rescue scenarios. They might have extremely tedious tasks, and you're dealing with the same group of people all the time. It's the same social dynamics. They have to constantly practice willpower and emotional maturity, and then of course there are the challenges with talking with Earth. So if there's anything negative that happens on Earth, what happens? They can't really do anything about it. Just a quick recap of our history of spaceflight. Cumulatively, this is the longest. Again, the Mars mission will be much longer. There's been prior evidence of psychological challenges and behavioral health challenges in historic spaceflight. For example, in the 1970s, during a Skylab mission, one of the crews thought that they were being overworked and that mission support was being unreasonable. So there was one day where it was the day of mutiny, where they turned off all the radios and just took the day off. And there are other previous and ongoing experiments that can inform us about long-duration isolation missions. So for example, in Antarctica, there's research where they have 9-month winter overs, and we've had evidence of subgroup formation, kind of small things turning into big deals, different behavioral problems. And the same have been observed in studies in submarine missions and other historic spaceflight. So the key problems are social monotony, that is, you're dealing with the same folks all the time in kind of the same context, and sensory monotony, not sensory deprivation, they're not being blindfolded or anything, but they're looking at the equipment, they're looking at the same things over and over again. These on Earth have been known to cause fatigue, drops in productivity, anxiety, hostility, risk-taking, rule-breaking behaviors, making you a really bad crewmate, really bad roommate. So we know we can't make light move fast enough, and we can't augment the lack of real-time communications. So we had a research question. Can we use virtual environments and virtual objects to help with the communications? After all, communication is not just language, it's also gestures, environments, and objects. So today we know virtual reality as this. I'll speed up my talk. But it's actually been around for a long time. Some argue that the first one was a link trainer, where they trained hundreds of thousands of pilots. And in the 60s, there were already commercial endeavors. The Sensorama, for example, had stereoscopic vision. And in fact, it had a little more than we have now. It even had aromas and wind. We heard a bit about Ivan Sutherland's work with graphical user interfaces and the first HR or VR headset, AR headset. There were a lot of different efforts in the 80s and 90s, including the failed Virtual Boy. And there was a lot of excitement back then. Movies were coming out kind of like right now. But ultimately, because of that lack of an ecosystem, a lot of that work remained in large institutions. For example, NASA worked with a data visualization helmet. And right now, they still train, they're upgrading their equipment, but they still train spacewalks and some of their safety procedures using VR. So in 2012, we had that famous Kickstarter, and that spawned this big industry. But in 2012, before the Kickstarter, NASA approached us and said, can we use VR to look at psychological health? And so we interviewed a bunch of astronauts. We went to some of their training facilities. And we brought a prototype, and we also went to a 12-month Mars isolation analog. This was a geodesic dome on an active volcano in Hawaii. And it turns out, this is the site, it turns out that parts of Hawaii, not the parts where you might want to be, but those parts actually look a lot like Mars. And so we had 6 crew members. These are mock astronauts. Who lived in the dome when they had the full delay communication. When they were outside, they had to wear spacesuits. And they lived in about 1,000 square feet of living space. They had their private crew quarters, they prepared their meals, they had a portal to look out, and they performed geological surveys. And they also had to connect with their friends and family, although they didn't have real-time internet. So we focused on the evidence-based strategies that we know on Earth works for improving psychological health. And this included giving them a freedom of choice, having a lot of nature-inspired scenes, allowing them for creative expression, and that killer app, social interactions with a variety of contexts, being able to receive virtual care packages, and then being able to be delighted by surprises. And we created a virtual environment based on the Open Simulator platform that we called Ansible. It contained about 30 or so different islands, from communication centers to campgrounds. So they could talk to their friends and family back home. There were a lot of different environments and activities that they can do. They could create kind of holograms of their avatars and partake in a number of different activities, going to different vacation spaces. We even had like seasonal activities. You could upload your own pictures, go skating, and experience different seasons. And we had some, not outreach, but the other way, kind of in-reach, I guess. We had a LA-based artist upload her work to give the crew an exhibit. Her work is about the new media and how that affects our own perception of self. We had a club lounge area where they could meet, they could watch movies, and they could talk to some non-player characters. So these were avatars that were simply scripted. And we had seasonal events like a Thanksgiving dinner. So the disc that you see there is essentially a recorder. Someone can throw a recorder down, they press the button, and then whatever their avatar is doing, including all of their actions, whatever they're saying, their gestures, movements are all recorded, so that when you go back, anyone else, or you could set different privacy settings, they could hit it, and then your avatar kind of spawns, kind of like the Princess Leia type of idea. And so when you have them all around the table and you press them all together, it looks like they're all having dinner together. So it's kind of like a asynchronous family dinner. We also had reminders of home with faux soundscape. Sounds very important. So you could sit on the front porch, listen to the birds, listen to the ice cream truck come by, and talk to your friends about your day. We also gave them their own environment so that they could customize different places using prefab furniture and various artifacts. And we found that, so we deployed this system with a group that was in the habitat for 12 months, and we compared it with a group that was in the same habitat, essentially very similar activities for 8 months. We found that the system was able to increase perceived closeness with friends and family. They reported greater social satisfaction, greater sense of social support, feeling closer to nature and closer to humanity at large. They reported a higher kind of speed and perception of time. This is important because when you're under extreme stress or extreme boredom, your perception of time tends to change. They also reported increased satisfaction of social interactions. So this is one of very few studies that really kind of took a very rigorous approach to look at how we can use VR as a new medium for social interactions. What are the challenges? Where do people really gravitate towards when they're talking to each other? Some of the kind of carry-on future work that I'm looking to do is extending this to isolated individuals in other populations. So whether it is the elderly in dementia or those with communication disorders such as aphasia and autism. I think that there's a lot to be learned about where we came from in terms of the history of VR. There's a lot of parallels now with what's going on and what has happened in the 90s, where there was a big hype and then it teetered down quite a bit. I'm also looking, because of my new role now at United Technologies, which is a Fortune 50 company, I'm looking at a lot of those industrial applications. How can we use VR for human-robotic interactions and machine-mediated human-human interactions? So that's the end of my talk. Thank you so much for your attention.